All right, let's talk about 6.6 number 21. All right, so this one says a 100-foot length of steel chain weighing 15 pounds per foot is dangling from the pulley. All right, so each foot of this chain weighs 15 pounds, all right? And we've got 100 feet of chain. Now, how much work is required to wind the chain onto the pulley? Okay, so let's take a look. So we can kind of think of it like, okay, so I'm not a great artist, right? But we've got this pulley, and I'm not drawing the other side of the chain because we're going to wind the chain around the pulley, right? But anyway, this chain's hanging down. It's hanging down 100 feet, and it weighs 15 pounds per foot. So to simplify matters, we could kind of think of it like all that weight is concentrated here at the end of the chain, right? And so if it's 15 pounds per foot and we've got 100 feet of chain, then that means we could think of it like we've got 1,500 pounds down there. So in order to overcome that, you're going to have to pull up with at least initially, you're going to have to pull up with a force of 1,500 pounds. Okay, or rather, if you're pulling on a pulley, then I guess you'd be pulling down with a force of 1,500 pounds at first. But as the chain winds, the weight here is less and less and less because more and more of the chain is around the pulley, and so you have less weight to pull. And that means the force that you're going to have to exert on the chain in order to continue winding it is going to decrease over time, right? So it's a variable force. So if we think about work, it doesn't matter how fast you pull the chain, because ultimately you have to move this weight a certain distance, and it's going to be the same no matter how fast or how slow you do it. The amount of work that you have to perform is the same no matter how fast or how slow you pull it. So you can choose any number you like. I'm going to choose a very convenient number and say, let's say that we're pulling the chain. So pull chain. Let's say we pull the chain at 1 foot per second. Right? So if you're pulling the chain at 1 foot per second, then that means each second of time that goes by, you lose 15 pounds of force. Right? You get to pull with 15 pounds less force, I suppose you could say. Right? So that the force function, f of t, well, at time t equals 0, you're going to pull up with 1,500 pounds. But then every second after that, since you're pulling the chain at 1 foot per second, every second after that, you lose a foot of chain, which means you lose 15 pounds of weight. So we're going to say minus 15t, where t is in seconds, right? So after the first second, you only have to pull up with 1,500 minus 15, with a force of 1,500 minus 15 pounds. After 10 seconds, right, you only have to pull up with a force of 1,500 minus 15 times 10 pounds, right? Anyway, so that would be the force function that you have to pull on the chain. And we have to move this thing 100 feet. So the amount of work required is going to be the integral from 0 to 100 of the force function, 1,500 minus 15t. Right? That's the amount of work that you have to do. So the rest is history, right? 1,500t minus 15t squared over 2. We evaluate this from 0 to 100, and you should get 75,000 at the end of the day. That's 75,000 foot-pounds. Okay, so that's that one.